In a very exciting news, GaLore Optimizer will soon be added to Transformers library. GaLore is a training strategy that allows full weight fine tuning of 7 billion parameter models on simply 24 gig consumer GPU cards, and that will be a real groundbreaking technology which is coming soon to the Transformers. So, you will be able to run 7 billion parameter models on simply 24 GB consumer GPU cards on your laptops once this GaLore optimizer is added to the Transformers library. Of course, you would have to upgrade the Transformers library if you have already installed it. This GaLore technology is based on this paper, and I would highly suggest to go through this because this is simply an amazing paper. The GaLore primarily stands for Gradient Low Rank Projection, and it is a memory efficient low rank training strategy that allows full parameter learning but is more memory efficient than common low rank adaptation methods such as LoRa. As a gradient projection method, GaLore is independent of choice of optimizers and can be easily plugged into existing one with only two lines of code. And those two lines of code are in there. I'll also mention in this paper, which you can read through, and I will drop the link in video's description. The thing is that LLMs have shown impressive performance across multiple disciplines, including conversational AI and also language translation. But pre-training and fine-tuning LLMs require not only a huge amount of computation, but is also very memory intensive. The memory requirements include not only billions of trainable parameters, but also their gradients and optimizer states. For example, gradient momentum and variance in Adam. That can be larger than parameter storage themselves. For example, pre-training a Llama 7 billion model from scratch with a single batch size require at least 58 gigabit of memory. And if you break down that 58 gigabyte, it means that 14 gig for trainable parameters, 42 gig for Adam optimizer states and weight gradients, and 2 gig for activations. This makes the training not feasible on consumer levels GPUs such as NVIDIA RTX 4090 with 24 GB of memory. And that is where this GaLore shines. Now the strategy is quite simple. It allows full parameter learning but is more memory efficient than common LoRa. And the key idea is to leverage the slow changing low rank structure of the gradient. Also, they have shown it theoretically in this paper, which I just showed you, that the gradient matrix becomes low rank during the training. And they have a lot of other stuff where they have demonstrated that GaLore works well in both LLM pre-training and fine-tuning. For example, when pre-training Llama 7 billion on C4 dataset, 8-bit GaLore combined with 8-bit optimizers and layer-wise weights update techniques achieve comparable performance to its full rank counterpart with less than 10% memory cost of optimizer states, which is amazing. GaLore is closely related to the traditional topic of projected gradient descent or PGD. But the key difference is that GaLore considers a specific gradient form that naturally appears in training multi-layer neural network. Now, there are a lot of mathematical equations and stuff scattered throughout the paper and also on this GitHub. And as I said, it is still a work in progress, but I think this memory efficient pre-training and fine-tuning strategy is going to stay, and it will be one of the top most way to run the models locally on your laptop with only 24 GB of VRAM. As soon as it is in production and we can get access to it through Transformers library, I'm going to make a video on a sample LLM and I will walk you through locally. That's it. I hope that you enjoyed it. If you have any thoughts, please share them in the comments. And if you like the content, then please consider subscribing to the channel. Thank you.